Hey there, guys. I'm Chris Escobar. So I'm supposed to make a video to teach you guys how to code, and I'm gonna keep it pretty basic. I'm just gonna go over how to code the what's this called? The Vex Mobibot. So it should be the hero bot too. And a few things I'm gonna be talking about is gonna be the controller buttons and axes. So that's gonna be the joysticks, and then Vex Hero Bot Mobi, which is this right here. Motor and controller setup. User control, specification, tank drive, if statements, controller setup, pros and cons, and then one joystick. So tank drive and one joystick are both different drivetrain coding methods or driving methods. So let's start off with the motor and controller setup. So real quick, before we start, I'm just going to show you the buttons on the controller. So we have up, down, left, right. Then we have axis 3, 4, 2, 1. And of course we have X, A, B, Y. But something that I do want to point out is that instead of going left to right from 1 to 4, we start off at 4 and end at 1. So that's just something you should keep in mind whenever you're coding this without a reference to the controller. And then another thing, we have button R2, R1, L2, L1. And just in case, people don't know what this right here is, that's the power button to turn on the controller. And then this is a screen that displays, what the controller is doing, what program you're going to use. Then this center hole right here, that's the charging port for the controller. And then the two outer ports, that's how you connect the controller to the brain whenever you're trying to set it up or you're just trying to do something else. So I guess we can get into this now. So, another thing I want to point out is that this is specifically used for VEXCode Pro V5. So remember that this is Pro, which is limited in the computers you can have it in. So not every computer like Chromebook or something similar to that can, for some reason, handle the software. So if you don't have a computer that works with this, then I would recommend you use VEXCode V5, which is click and drag, or they also have the option for text coding, but I'm not too good at that one. I think it's a slightly different language. It might not be, but I think it is. But if you guys do need help with the VEXCode V5, which is in the Pro, and you need help with the click and drag blocks, then you should, text Kevin in the Discord chat, and he'll be able to help you out. But if you guys need any help related to this, so that this is Robot C++, then I can help you out anytime. So first off, you go to File. Whenever you open up the software, you go to File, you click New, and then you're gonna get an option to name your project. I named mine Mobibot, just because that's what I'm going to be coding this time. And as soon as you get in, this is the screen you're gonna get. Yeah, that's something else I did. So this is the screen you're gonna get, and what you want to do first is look at this and then this green text over here. I want to point out that the green text everywhere is a line of text in the project, but it doesn't affect the code at all. So you could like be right here. You could click two forward facing slashes and you type something like move forward. So technically the robot won't move forward just because you texted that. I mean, just because you typed that in, because it's not an actual piece of code. It's just there as a note that you can make towards yourself or something similar to that. So nothing big really. So you could go ahead and delete this. And before we start coding, you guys need to go up here, top right of the software. And the third button to the left is going to be some sort of weird shaped thing. It looks like a port from the controller. So you just click on that, and that's going to be robot configuration. So let me just delete all these because I put them in before. Okay, so first thing that you're going to do is click add a device. So you click that and you add a controller first. You don't mess with any of the buttons here because you could click them, but I don't recommend doing that right now. I'm going to save that for the end of the video. So you click done and then I just want to show you guys. So we have 4 total motors, and that's going to be 2 used for the drivetrain and then 2 used for the forklift mechanism. So what we want to start off with is we're going to do port 1 is going to be our left back motor. So that just means that it's on the left side of the robot in the back. So left back. And we don't need to mess with the gear cartridge or the normal reverse because that's the gear cartridge is for gear ratios and something else that you might want to do with it. And then normal reverse, that just flips the way that the motor is going to be working. So because I want to show you how you can fix that in the actual code itself, I don't really want you guys to click this because you guys are kind of going to mess up in the actual code. So you just click done for now, and then you go back, and then on port 2, you're going to name it right back. So again, we don't mess with anything else. And then that's just going to be on the right side on the back, this motor right here. And let's see. And then we got the 2 front motors. So we got port 3, left front. Oops, misspelled that. Left front, we don't mess with anything. Then one more in port 4, that's going to be right front. And whatever these numbers on the sides are, that's where you're going to connect your motors in the brain. So the left back motor is going to be connected to port 1, right back to 2, left front to 3, right front to 4. So that's something you want to keep in mind, or else the code isn't going to distribute properly to the right motors, and you're just going to have a whole bunch of confusion. But it's really easy to fix. You just got to go back and then rearrange your wires to the right ports. And so yeah, we deleted what we had to delete. Then the next step would be user control and specification. So whenever you're telling your bot to do something, so for example, you're telling it whether or not you're going to control it or it's going to control itself. So that means autonomous and user control. You want to actually tell the robot that it's going to be something specifically. So if you're going to be controlling it using a controller, you're going to say user control. But if it's going to be autonomous, so like that just means that the robot is going to be moving around by itself using the code you put before, then it's going to move on itself. You won't have to click any buttons or anything. But that's not what we're doing right now. We're going to code it so that you can drive it yourself. So we're just going to go, oh yeah, I guess we could just do that. Okay. We're going to click void, or type void, then user control, then in parentheses void again, and then I believe it's that, yeah, okay. And then these wavy brackets sort of thing. So then what your code should look like is what mine looks like right now. So it's gonna say int main parentheses and then these, wavy brackets. And then so the brackets just mean, if you have some experience in coding, then I'm assuming you should know this. It just means that everything in between those two is directly related to it. So like void user control void is right here, like it's part of the main whatever. And then void user control is gonna have a few things inside of it. So we're gonna go with while one. While one just means while this is true, it's going to happen. So while everything in between these two wavy brackets, that's right after while, everything in between those is going to be part of user control, and everything that's in between that is going to be part of the main part of the brain of the code. And then it's all going to occur if it's real. If it's happening, it's going to happen. So we already got everything set up. That's what that is, void user control, and then while one. And then if you want to make this autonomous, it's really simple. You have the same stuff, except this is going to change to autonomous like that. And then it's just going to look like that. But right now, just because we want to code it for driving, we're going to say user control. All right, and then we already got here. My bad. All right, so first off, we're going to be coding a tank drive. Okay, tank drive drivetrain. So what this means is that whenever you push these two joysticks forward, the robot's going to move completely forward. But if, let's say, you move axis 3, so that's this one. Let's say you move axis 3 up, and then axis 2 is just stationary, then what that's going to do is that's going to make the left side of the robot move forward, while the right side of the motor of the robot just stays back. So technically you need to like control both joysticks in order to control the entire robot. So now that we got that settled, we can actually start coding it. So like I said, these green things are like bookmarks or whatever in your code. I'm using it to keep you guys, specified on what I'm on, but you can use it for whatever really. So then we got tank drive, and yeah, so first thing we're gonna do is we're gonna name the motor we want to control right now. So we want to control left back, and then we want to say what it's gonna do. So we put period spin because we want the motor to spin, and then we're gonna put vex because that's what we're using. We want to specify. Well, for some reason, just vex specifically needs us to say that we're using vex. I'm not really sure if it's like this for everything, but as far as I'm concerned, that's what vex does. So we've got to put vex direction units. Oops. Direction type, my bad. Direction type, then 2 colons, and then we're going to put FWD. So down here is going to give you the option to click forward. So if you click that, it's going to say it's incorrect, and it technically is. You could fix it, but instead of going around just redoing everything that you already typed in, just click forward, FWD, and you should be good. So I'm just going to tell the motor that it's going to spin forward and not reverse. So you got 2 directions, that's going to be forward and reverse, and right now it's going to be forward. So we already got that settled. Then we put a comma. Now we're going to set the speed, what we want the percentage of the speed to be. So controller 1, because this is specifically to speed, I'm going to be using the controller and the axis. So controller 1, axis 3, because then again, we're going to be controlling the left side. That's axis 3. Dot position, then 2 parentheses. Yeah. Let me just put that back. Okay. So controller 1 dot axis 3 dot position. That just means that the position of the third axis, so the left joystick, which is going to be up down, that's going to be the percentage. That's why we have these 2 parentheses that it's going to have when controlling the speed. And then because we want to specify that this is speed and not something else, we're going to say vex velocity units. Oops, velocity units. And then we're going to say PCT because it's already been named. The percentage has been named right here. We don't need to rename it. We don't really need to do anything else. It's already there. And right here, we're going to put the semicolon. And then for this, we need to do the right back motor now. So right back dot spin. And you could copy and paste all of this and just, copy it and then paste it right here. But honestly, I'm just going to type it out just so you guys can get it. So that's going to be vex direction type. And this one's going to be different. So it's going to be REV for reverse. And again, this is just going to tell you it's incorrect. So we should just keep it at REV. It's going to tell you it's reverse because these 2 motors right here, this one and then this one, are flipped. So whenever one is going forward, the other one's going to be going backwards. So we got to specify that we want both of them to be facing the same way. To be rotating the same way. So that's why we put one forward and one reverse. And you'll notice that sometimes you got it incorrect. Like maybe you put this one reverse and this one forward and it was supposed to be flipped. So you could just come back in the code and instead of forward, just click reverse. Instead of reverse, just click forward. And then again, we're going to do controller 1. But instead of axis 3, we're going to do axis 2. Because this is controlling the right side of the robot. We want the right joystick to be up, down, which is axis 2. And then again, the same thing, position, comma, vex, velocity units, and then PCT, because we already stated the percentage of the speed. All right, and that's basically it for the tank drive. So let me just rename that DriveTrain. So we're done with the DriveTrain. So now whenever you hook this code up to your actual brain, if you control the two axes, like both of them forward, you can drive. Everything else isn't going to work, the two other motors, but it is going to still, work in terms of driving forward. So now let's look at what's next. We got if statements. So we're only going to use two, I believe, because it's two motors controlling the forklift, which is going to be this motor and this motor, which we named right front and a left front. So let's go here to forklift. I'm going to name it. Okay, and you can name these motors anything you want, but right now I'm just naming it this to keep it, pretty simple. So we can start off with left front. Well, actually, yeah, you don't start off the same way that you start off with DriveTrain. This is going to be different. Since this is an if statement, I should probably clarify that. If statements. Okay, so this is an if statement. You're going to start off with if, then in parentheses, because you're setting the condition, it's going to be controller 1, period, not axis. This is going to be button, and this is up to your team really, because your team has to decide which button they're going to think is more efficient to use when you're controlling the up down of the forklift. Now let's say my team decided to do button R2 for up and then button R1 for down. Then we would go right here, type in R2 dot pressing. We want it to be pressing in order to activate this if statement. If it's just pressed, that means that as soon as you press the button, this is going to activate. But if it's pressing, then while you're pressing it, then it's going to happen. Otherwise, nothing's going to happen. I don't think I need to put one of those, my bad. Yeah, there we go. And normally that's going to happen if you don't put a space in between the wavy bracket and parentheses. So I recommend you doing that, or else you're going to have to retype it. So don't get confused about it. You just got to retype the two parentheses. So if controller 1 button R2 is pressing, then we want the robot to, okay, there we go. Then we want the robot to make the motor spin. So what motor do we want it to spin? We want the left front dot spin. So we want that motor to spin at vex direction type. And we want this one to spin forward just in case, because we still don't know which way your motor is facing. So we're just going to assume it's forward for right now. Then comma. And because this is a button and not an axis, we can't really say if this button is being pressed with this much strength or something. You have to say a percentage now. And I believe it's a scale from 0 to 100. Although I think I heard someone mention that you could go higher than that, like up to like 127. But for right now, I think I'm just going to keep it from 0 to 100. So a speed that I like to start off with whenever I'm unsure of something is normally 50. So that means it's going to be 50% of the total speed. And so the motor is going to rotate 50% of the total speed whenever you're pressing R2. So we just type in 50 and then vex velocity units, and then PCT, because we already stated it right here. So that's just going to be the speed. So keep that in mind. Then we have else if. What is it? If else? No, I think it's else if. Okay. Else if. So this is the counter. I don't know how to call it, counter condition or something. It's just going to be the reverse of what you already put. So we already told the robot how we want the arm to go up. So like we already told the robot how we want the forklift to go up, but now we got to tell it how we want it to come back down. So normally you want to use like opposites. You don't want to use one like button R2 to go up and then button B for going back down. You normally want to use like R2 R1 or L1 R1. Not something so random and split up. So right here, let's just say my team decided to go with R1. There we go. Pressing. So while button R1 is pressing, oh man. While button R1 is pressing, this is what's going to happen. So we're going to put the left front motor. Okay, left front dot spin. Vex velocity units. And right now we're going to want to reverse it because we want it to go back down instead of up. Oh, why am I typing velocity? That's my bad. I meant direction type. So direction type, 2 colons, and then this one's going to be reversed, so REV. And we want it to be relatively the same speed. I mean, unless for some reason you want it to go slower or faster, you could change it, but for right now, let's just keep it at 50, same speed. And you could actually mess around with the speed. If it's too slow for you or too fast, you could always make it lower or higher. Then we just gotta set that we already mentioned the speed. So velocity units, PCT, and then the semicolon. And then now we have the final condition. So we told the robot what we wanted to do to go up. We told the robot what we wanted to do whenever we wanted to go down. Now he's got to tell the robot what we wanted to do while we're not doing anything with those two buttons. With R2 or R1, what are we doing? What is the robot doing while we're not doing it? So right now we're just going to type in else, nothing after it. And then we're going to do the two parentheses. I mean the two, my bad. Two closed bracket, two wavy brackets. So else left front dot stop. We want the front motor to stop. We don't want it to keep moving. We don't want it to keep spinning. We just want it to stop as soon as we stop clicking anything. And we're going to name this Vex break type because we want it to break. As in, like stop, not break as in, oh, let's go break something. No, so the break type is going to be a hold. The reason we're choosing a hold over any other break type, which I think are like 2 more, is because we want the motor to be able to hold whatever we're carrying without dropping it. So if we have something like a break type break, then the moment you let go of one of those buttons, this entire arm is just going to fall right down. Even if you're carrying the mobile goal or whatever, it's just going to go down. It's not going to hold it there or anything like the break type hold. Hold is most definitely going to hold it, and it's just going to keep it there. But otherwise, it's just going to fall back down or conserve energy for some sort of break type. But I don't really know too much about that one. So yeah, for this one, we're going to use hold. And then we're basically going to redo all this, but for the right front motor. So we're going to do if and controller1 button R2, because we don't want to switch these buttons, because that way, whenever you're clicking just one button, you're controlling one or more motors, which is a lot easier than having to click 7 buttons for 7 motors. So dot pressing, again, that doesn't change either. Okay. And then this one we want it to be relatively the same. It's going to be right front dot spin vex direction type. And this is going to be reversed. So whenever you're making the opposite motor and they're on opposite sides, like these two, you're going to switch these up. So instead of forward, we're going to have reverse. And then same speed all the time. Especially for the Mobibot, we have it connected using this metal rod. This, is it aluminum? Yeah, aluminum rod right in between. And it's connected straight to both arms, which forms the forklift. So as soon as you put a speed that's like any faster than the other, then it could potentially break, and we don't necessarily want that whenever we're in a competition or something, or just practicing in general. So you really want to be careful about keeping the speed the same. So if you switch this one for 75 and you forget to switch this one, just double check your code all the time. The chances of it breaking fast, it's quite low, but while you're testing out your robot, I definitely recommend you pay attention to anything that could go wrong. So then we already named the speed. Let's go to else if. So again, the same thing, controller1 dot button, I believe it was R1. Yeah, R1 dot pressing. Okay, and then enter. Okay. So else if we're going to put right front. We want it to spin the opposite way. So spin, vex, direction type. Oh, and actually, that's my bad completely, guys. I forgot to mention that whenever you're coding in robot or just C++, the first word of your code, like direction, is going to be all lowercase. But the first letter of your second word is going to be uppercase. So it's going to be capitalized. So like direction type, everything's uncapitalized except for that one T. Same thing in velocity units, everything's capitalized except for that one U. And then break type as well. So the first word isn't capitalized. Second word only has the first letter capitalized. I'm so sorry, I forgot to mention that. But that is something you should keep in mind. I'm probably going to put it in the description or something. But yeah, direction type, this is going to be forward because we want it to be opposite of this one and opposite of this one. So forward, same speed though, so that's going to be 50. Vex, velocity units, PCT. And then the final part of the code is going to be else. So else, and the two wavy brackets, and there's going to be right front, and then again, oops, that's my bad. Front stop, dot stop, or period stop. Then vex break type. Oops, yeah, see right there, I forgot to capitalize. All right, and then break type hold. And that should be it. Yeah, guys, and so that's it for basic text coding. And you know, this entire software is text coding. There is no drag and drop blocks. But there is one more way to do it, and I'm about to teach you that. So, oops, let's see what we just did. So we did this. Okay, so now we're going to talk about controller setup. Instead of actually writing or typing in the entire code, there is something you could do. So let me just save this real quick. Let's go to new, and we're going to name this, well, I'm going to name it controller setup. All right. So again, you're going to start off the same way. You're going to go up here, add a device, and actually, whenever you're coding in controller setup, you're going to want to use a DriveTrain. Instead of using individual motors like we did for the actual code, you're going to use a DriveTrain. So DriveTrain, 1, 2, we don't have any of that, or I mean, your team might, but my team does not. So whenever you're using some of this, it's normally for autonomous or something else, and normally it's not used at all. So you can just click done. So we have the DriveTrain setup. So that's going to be port 1, port 2. And now we can add a motor group. Yeah, okay. So let's do 3 and 4. And we're going to reverse the fourth motor on the fourth port. We're going to reverse it because these are going to be the forklift motors. So we want one of them to be reversed. And I actually forgot to do that for this one. Oh, but it doesn't really matter. That's my bad. Does it though? I forgot. Yeah, I doubt it matters, to be honest. Yeah, it does not, as a matter of fact. So whenever you're using this, you're gonna add the controller at the very end. So after you added the drivetrain and whatever motor group you have, or just individual motors, you're gonna click controller, and then right now it's gonna code the drivetrain. So if you want a single joystick drivetrain, you just click on one joystick, and that one joystick rotates the bot and moves it back and forth. So you don't have to do anything for the drivetrain. So a pro for this would be, you know, you get fast and easy coding. You barely even have to text anything really. All you have to do is just click buttons. And then let's say we want to do the same thing we did with the other bot, with other code, where we want the forklift to be controlled using this. Then we can just do this. See, forward and reverse. I think it works right like this, yeah. And then you basically have it like that. And then you coded everything that we just did, like for the past 20 or something minutes. You just did right here, all in one go. And that's really great. If you're going for speed and everything, that's really great. That's really great. Don't get me wrong. But a huge issue you're gonna notice as soon as you start driving is that the controller doesn't account for break types. So the break type that I mentioned before, hold, is unique. It holds whatever you have. It does not just break and then drop. But whenever you're using controller, it uses break. So it automatically uses break. So as soon as it breaks, like you stop using it, the entire thing is just going to go straight down. And you're going to drop the mobile goal and everything, and it's not going to work. I actually just realized that just a couple weeks ago. But yeah, just, really watch out for that. And yeah, and then you got the motor group set up and everything. And basically that would be the only con I could think about for the fast coding. And I'm not even sure if you could fix it. If you could fix it in terms of the code, because I've never really tried it before. You could try searching it up on YouTube or on Google, and it should work. And then we already talked about the one joystick drive, which is this right here. You could also make this into tank drive. I don't think that has any problems with it. It's like that, where it just makes it into a simple tank drive, and you got all joystick. And yeah, so that's basically it for the coding and everything. I taught you guys how to code two ways, which is going to be the one joystick drivetrain way, which is controller setup, and then the actual text. So I hope this helped out, and it took me half an hour, but that's cool. But yeah, guys, if you guys need any help, just text me or Kevin in the Discord chat, and everything should be good. All right, see ya.